Hi, welcome back. This is Rakesh Naik. Today we are going to learn about how to compare two functions asymptotically. But before we start, a small information I'd like to share. As you know, we produce every video in two different languages. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. In our previous videos, we have seen how to find complexity of iterative function and a recursive function. Now, if two functions are given, how to find which function is reaching infinity faster? Or in other words, I want to find the order of growth. So basically, measuring the performance of an algorithm in relation to the input size is called order of growth. So this is the basic graph of order of growth. In x-axis we will take the number of inputs, and in the y-axis we are going to take how it is growing. You can see the function which is linear. It means if n is equal to 1, it will take 1 unit of time. If n equal to 4, it will take 4 unit of time. If n equal to 128, it will take 128 unit of time. Like that it will grow. And you can see the quadratic equation. N square, it will go in the form of square. If n equal to 2, it will take 4 unit of time. If n equal to 8, it will take 64 unit of time. In this way it will grow. So what we are going to find when we are trying to find the order of growth? We are trying to find which of the function is reaching infinity faster. That is the problem that we are going to learn today. So in order to compare two functions, there are few thumb rules. Let us see them one by one. The first one is, if two functions are given, first of all drop any constant if it is given from the beginning itself. And the second step is, drop any lower order polynomial. The third step is, any polynomial dominates any logarithms. The next rule is, exponent function dominates the polynomial function. And if x to the power n dominates y to the power n, then we can say x is greater than y. So these are the few rules that we need to remember before we go to find the order of growth. Basically, we adopt two methods to compare order of growth. First one is logarithmic method and the second one is L'Hospital rule or L'Hospital method. Sometimes we say limit method also. So let us learn them one by one. So before learning the logarithmic method, let us see some useful identities because we are going to use them very frequently. If we are having 2 to the power 3, we know that the value is 8. It means in the form of logarithm, if you want to write, then we can write log base to 8 equal to 3. It means log n is the power to which you raise 2 to get n. Then what are the identities? You can say log 2 to the power n is n, log x to the power y is same as y log x, log xy is same as log x plus log y. So in this rule, we are going to change the base. So log base to x is nothing but log base k x by log base k 2. Few more rules are there. Log 2 to the power log n is nothing but n. 2 to the power x to the power y is nothing but 2 to the power xy, and 2 to the power x into 2 to the power y is nothing but 2 to the power x plus y. These identities are very, very essential when you are finding the order of growth using logarithmic method. Let us try to do and understand an example. If fn is a function given, that is 3n cubed, and gn is another function given, 5n log n, then we have to find the function which is having higher growth rate. The first step we need to do is to drop the constants. So we are having 3 and 5 constants here in fn and gn. So after dropping the constant, we will get fn equal to n cube and gn equal to n log n. Now take log both sides. If you are taking log both sides, it will be log n cube for fn, and if we apply the identity, it will be 3 log n. And 3 log n we can write 2 log n plus log n. Similarly, for the other function, log of n log n. Again, we are in the form of multiplication. We can say log n plus log n. Now on both sides we are having log n. So we can cancel it out and we can see 2 log n is always greater than log n. So we can say the function 3n cube is having higher growth rate than 5n log n. I hope you understood how to apply logarithmic method in order to find the order of growth. Let us learn L'Hospital method or limit method. If fn and gn, two functions given, and if limit fn by gn as n tends to infinity are in the form of infinity by infinity or 0 by 0 form, then we apply L'Hospital method. You might be learning this at intermediate level. Let us try to apply it. Now, what we generally do, we keep on differentiating the numerator and denominator separately till we get a finite value as n tends to infinity. It means we will take limit fn by gn as n tends to infinity. It will be same as limit f dash n, g dash n as n tends to infinity. Is same as limit f double dash n, g double dash n as n tends to infinity. We will continue till we find a finite value. Let us try to do this with the help of an example. If fn is greater than 0 and gn is greater than 0 for all n greater than equal to r, where r is some real number, then these are the rules that we need to apply. If limit fn by gn equal to infinity as n tends to infinity, then we'll say fn is greater than gn. It means fn grows faster than gn. The second rule is if limit fn by gn equal to k, some constant value, as n tends to infinity, then we'll say fn is greater than gn. It means fn is greater than gn. It means fn grows k time quickly as gn. And the last one is if limit fn by gn equal to 0 as n tends to infinity, then we can say gn grows faster than fn. We need to apply this formula in order to find the order of growth using limit method or L'Hospital method. Let us try to understand this with the help of an example. Here fn equal to 3n cube and gn equal to 5n square. So what we are going to do, we need to drop the constant at the beginning itself. From fn we will drop 3 and from gn we will drop 5. So the reduced function will be fn equal to n cube and gn equal to n square. Now what we need to do, we need to take limit. Limit n cube by n square as n tends to infinity. Now you can see it is in a infinity by infinity form. So we need to apply L'Hospital rule. So in L'Hospital rule, what we do? We differentiate the numerator and denominator. So if we differentiate it, we will get 3n square in the numerator and 2n in the denominator. If we again take limit as n tends to infinity, again it is an infinity by infinity form. Again we will apply L'Hospital rule. Again we are going to differentiate the numerator and denominator separately. So we will get 6n by 2. Limit 6n by 2 as n tends to infinity is infinity. We got a value as infinity, and according to the formula we can say g grows faster than, because 3n cube is greater than 5n square. I hope you understood this also. Let us do some extra problem so that you will be able to understand it properly. Fn equal to log n to the power half and gn equal to log n. So how we are going to find the order of growth? As we know that we need to drop the constant at the beginning. There is no constant. Fn and gn remains the same. We are going to take log both sides. So we will be having log n to the power half, and it will be reduced to half log n. On the other hand, log of log n becomes log n. Now if we will substitute n equal to 2 to the power 10, then we will get this value substituted here. And if we want to reduce it, first log will be getting cancelled and the value will become 2 to the power 10. Means half log 2 to the power 10 for fn, and for gn it will be log 2 to the power 10. Again one more time we can cancel it out and we'll get half of 10 equal to 5 and log 10 is approximately 3. So 5 is greater than 3. You can say Fn grows higher than Gn. Let us take one more problem. Fn equal to 3 to the power n and Gn equal to 2 to the power n. Take log both sides. So we will get n log 3 and for Gn we will get n log 2. And if we will cancel out n, we will having log 3 greater than log 2. So we can say Fn grows faster than Gn. One more problem. Fn equal to n to the power log n and Gn equal to n log n. And we need to find the order of growth. Now there is no constant, so no need of dropping any constant here. Take log both sides, we will be getting log n, and for Gn we will get log n plus log n. So if we will substitute n equal to 2 to the power 2 to the power 10, we can get log Fn becomes 1024 into 1024 and log Gn becomes 1024 plus 10. So which one is greater? Fn is greater, so we can say Fn grows higher than Gn. Let us take one more problem. Fn equal to 3 e to the power x and Gn equal to 5 x to the power n. And we need to find the order of growth. Here 3 and 5 are the constants here, so we need to drop it. And we will be comparing Fn equal to e to the power x and Gn equal to x to the power n. Now let us take limit. Limit e to the power x by x to the power n as x tends to infinity. It is in infinity by infinity form. So we are going to apply L'Hospital rule. So differentiation of e to the power x is same e to the power x and differentiation of x to the power n is n x to the power n minus 1. Now again it is in infinity by infinity form as x tends to infinity. Again apply L'Hospital rule. Now the second time e to the power x remains the same and the denominator will be n into n minus 1 x to the power n minus 2. So if we continue doing like this, after some time the denominator will be coming to 1 and you can see the denominator coming to 1, the denominator becomes 0 and the value of limit as x tends to infinity will be infinity. So 3 e to the power x will be greater than 5 x to the power n. So we can conclude that Fn grows faster than Gn. One more problem. Fn equal to log x and Gn equal to x. Let us see. There is no constant, so we need not do anything here. And we are taking limit. So limit log x by x as x tends to infinity. You can see here it is an infinity by infinity form. So we are applying L'Hospital rule. Log x differentiation is 1 by x and x's differentiation is 1. So limit of this as x tends to infinity is 0. So log x is less than x. So we can conclude that gx grows faster than fx. I hope you understood all the different type of problems that we discussed here. You practice little more for your better understanding. So if you understood, give me a like and share among your friends. See you in our next video. Till then, take care. Bye.